How do you stop an AI from hallucinating and make it understand your private enterprise data? Today, we architect RAG and fine-tuning. Welcome back to the AI Vanguard Masterclass, where we transition from theoretical models to practical, secure enterprise integration. In our previous session, we established the mathematical foundations of generative models. Focusing on the transformer architecture, we recognize that while large language models are incredibly powerful cognitive engines, they possess a critical operational limitation. Their core knowledge is completely static, frozen at the exact moment their initial, computationally expensive training phase was completed. Furthermore, out of the box, they have absolutely no access to your proprietary corporate data or secure business databases. If you ask a foundational model about a private corporate policy, it will either fail or confidently hallucinate a plausible fiction. To deploy generative AI in a secure enterprise environment, we must bridge the gap between the model's reasoning and your private data. There are two primary architectural frameworks to achieve this vital integration: Retrieval-Augmented Generation, commonly known as RAG, and model fine-tuning. It is a common misconception among business leaders that to teach an AI your data, you must fine-tune the entire model. This is architecturally incorrect and often leads to massive, unnecessary computational expenses and failed digital transformation initiatives across the enterprise. Let us begin by thoroughly dissecting Retrieval-Augmented Generation, as it is the most critical infrastructure for factual accuracy. RAG is essentially an architectural bridge connecting the language model's reasoning engine to an external, dynamic knowledge base. Instead of trying to force the AI to memorize your data during a training phase, RAG allows the model to actively read your data. Here is how the mechanism functions in practice. First, your enterprise documents are converted into a mathematical format called vector embeddings. These complex mathematical embeddings represent the exact semantic meaning of your text and are stored in a specialized infrastructure known as a vector database. When a user submits a query, the system does not immediately send that prompt directly to the large language model. Instead, it performs a high-speed semantic search within your secure vector database to find the most relevant paragraphs or documents. The architecture then retrieves that specific proprietary information and dynamically injects it into the prompt alongside the user's original question. The large language model receives the question, plus the exact relevant data required to answer it. In a single operational package, it uses its cognitive reasoning capabilities to synthesize the retrieved data, providing a highly accurate, contextually aware, and verifiable response. RAG offers three massive advantages for enterprise deployment, making it the industry standard for factual data retrieval. First, it drastically reduces hallucinations by grounding the model in verifiable facts that you control within your own secure environment. Second, it allows you to update the model's knowledge instantly simply by adding or removing documents from the vector database. You do not need to retrain the underlying model, saving hundreds of thousands of dollars in cloud computing costs and engineering time. Third, RAG perfectly respects enterprise security permissions. If a user lacks clearance for a document, the retrieval system will simply not access it. Now, let us examine the second architectural framework, fine-tuning. This is a fundamentally different approach to modifying artificial intelligence. Fine-tuning does not give the model access to an external database or real-time information retrieval systems. Instead, it permanently alters the underlying neural weights and mathematical parameters of the generative model itself. You achieve this by providing the model with thousands of highly structured examples of the specific inputs and your desired outputs. The model undergoes an additional targeted training phase, adjusting its internal architecture to perfectly mimic the patterns in your dataset. If RAG is about giving the model a textbook to read, fine-tuning is about changing the model's fundamental behavior and vocabulary. Fine-tuning is absolutely the wrong choice if your goal is simply to teach the model new factual information or changing company policies. It is highly inefficient for fact retrieval, and the model will still inevitably hallucinate when asked about highly specific corporate details. However, fine-tuning is the superior architectural choice when you need the model to learn a highly specialized task or specific format. For example, if you need the AI to consistently write programming code in a proprietary, undocumented language specific to your company, or if you need an autonomous agent to perfectly mimic the exact tone, cadence, and conversational structure of your senior brand representatives, fine-tuning excels at behavioral adaptation and format adherence, transforming a general-purpose model into a highly specialized corporate tool. In the most advanced enterprise architectures, these two methodologies are not mutually exclusive. They are combined for maximum operational efficacy. You can fine-tune a smaller, more efficient open-source model so that it thoroughly understands your corporate tone and operational formats. Then, you implement a robust RAG architecture on top of that fine-tuned model to provide it with real-time, accurate factual data. This hybrid approach creates a highly specialized cognitive engine that speaks your language and possesses instant recall of your secure databases. Understanding this distinction is what separates standard IT administration from true enterprise artificial intelligence architecture and leadership. Deploying generative AI without RAG is a massive security risk, practically guaranteeing hallucinations and operational failures in production environments. Conversely, fine-tuning a model solely for knowledge retrieval is a massive waste of computational resources, time, and digital transformation budgets. As technical leaders, it is your responsibility to thoroughly evaluate the specific business use case before selecting the underlying infrastructure. You must ask your engineering teams, are we trying to change what the model knows, or are we trying to change how the model behaves? If you are expanding its knowledge base, you must architect a retrieval-augmented generation pipeline using robust, scalable vector databases. If you are altering its behavioral framework or enforcing a strict syntactical output, you must invest in high-quality fine-tuning datasets. This single architectural decision will dictate the scalability, security, and ultimate success of your AI integration initiatives across the company. In our next masterclass session, we will push beyond the processing of simple text and explore the frontier of multimodal neural networks. We will examine how modern systems process vision, complex audio, and video inputs to execute reasoning across multiple sensory domains. This will provide the foundation for understanding how autonomous agents can eventually interact with digital environments just as human operators do. To ensure your engineering teams can practically implement the RAG and fine-tuning architectures discussed today, I have provided technical documentation. This companion guide details the specific Python libraries, vector database structures, and embedding models required for secure enterprise deployment. It outlines the exact cost-benefit analysis frameworks needed to justify these critical infrastructure investments to your executive leadership boards. You can access this comprehensive documentation immediately in the professional GitHub repository linked in the video description below. I strongly encourage you to review these architectural diagrams with your data science teams to perfectly align your corporate digital strategy. Building the AI vanguard requires a rigorous commitment to understanding the underlying mechanics, not just using the surface-level chat interfaces. Master the difference between knowledge retrieval and behavioral adaptation. Subscribe to the masterclass, download the GitHub guide below, and join the vanguard.